All right, here are the answers to today's schema. I will go back and re-explain how to do each example. So check your answers here first. If you got them right, you can fast forward to whichever question it is that you need an explanation of. I will also go through what a good example of something to write for number 5 would be as well. So pause here, check your answers for 1 through 4, fast forward through if you don't need an explanation, or fast forward to whichever one you need specifically. All right, so for number 1, we're going to look where the x is, and so I see the x is right here. And what's happening on the same side as x is I have this 9 being added to it. Now, it is a positive 9, even though there's not a plus in front of it. This plus actually goes with the x. So if I look at 9, it has no sign in front of it, no symbol. That means it's a positive 9. So in order to move that 9 away from the x, to isolate the variable, to get the x by itself, I have to do the opposite of positive 9. I actually have to do the inverse operation. So it's a positive 9, which means we need to subtract 9. And I'm going to do that on both sides of my equation, like this. So notice I did it underneath the 9 because I want to do the inverse to cancel that out. But then I went past the equal sign and did it under the 23 as well, so that I keep my equation balanced. So after I write that on both sides, it's really important that we show our process, so that's why I'm stressing showing the work here. 9 minus 9 cancels out. I'm going to cross that out. And I'm left with just the x, so I'm going to bring the x down. And bring down my equal sign as well. Don't forget that. We're interested in knowing what x equals. And so over here, I just have to do 23 minus 9. 23 minus 9 is 16. So my answer for x is 16. If I think about it really quickly, 9 plus 16 gives me 23. So I know that that makes sense. All right, number 2. This one's a little bit different. If we notice here, we have this coefficient, negative 3, and then we have an x. And what that means is that negative 3 is being multiplied by x. So that's all I have on this side of the equal sign. So in order to isolate the variable here, I have to get rid of this negative 3. Now we said it was being multiplied, and so the inverse operation of multiplying is dividing. So I'm going to divide both sides by this coefficient of negative 3. Both sides of the equal sign. So I'm going to divide it here so that these negative 3's cancel out, and I'm left with 1x. Bring down my equal sign. And over here, 18 divided by negative 3 is negative 6. Now remember, 1x is really the same thing as x. Sometimes people like to write the 1, and then they like to rewrite their answer as x equals negative 6. Once I have my x by itself with just a 1 in front of it, a positive 1, then I know I've solved for x. Number 3. So this time I have x is being divided by 4. Then 3 is being added to it. And then the answer, whatever happens after that, equals negative 2. So in order to figure out what x is, I've got to undo both of those operations. I always start with the adding or subtracting if it's a two-step equation. So I see that 3 is being added, positive 3 here, is being added to x. So I need to do the inverse operation. So I need to subtract 3. I'm going to subtract it under the 3 so that those cancel out. I'm going to go over to the other side of my equal sign and subtract it under the other constant, negative 2 minus 3. So I didn't do anything with this x divided by 4. I'm going to bring it down, carry it along, because that's what I have left on that side of the equation. I'm going to bring down my equal sign because my 3 and negative 3 canceled out. And then I'm going to do my math. Negative 2 minus 3 gives me negative 5. So I have x divided by 4 equals negative 5. And now if I have divided by 4, the inverse of dividing is multiplying. So I'm going to multiply both sides by the denominator. The denominator is 4, so I'm going to multiply both sides by 4. And I'm going to write it on both sides of the equal sign. And what that's going to help me do is this times 4 and this divided by 4 are going to cancel each other out, so I can cross that denominator off. And all I'll have left is just the x. So again, that's 1x, because 4 divided by 4 is 1. On the right side, I have negative 5 times 4. I have to do the multiplication over there. There's nothing that's going to cancel out. Negative 5 times 4 is negative 20. So my x is equal to negative 20. On to number 4. So I have 5x minus 8 equals 12. So this again means 5 times x, if I want to put a little dot there, minus 8 equals 12. We start with since there are no fractions here, we start with the subtract 8, and we want to get rid of that first. We try to do our adding and our subtracting first. We can deal with the fractions afterwards. In this case, there aren't any fractions, so it'll be a little bit different at the end. So I have minus 8. I need to do the inverse of minus 8, which is add 8. So I'm going to add 8 underneath the 8. Go to the other side of the equal sign and add 8 as well. I'm going to bring this 5x down because I didn't do anything with it. Negative 8 plus 8 is going to cancel out. Bring down my equal sign. And then 12 plus 8 is going to be 20. So I have 5x equals 20. And again, remember, that's 5 times x equals 20. So if I want to undo times, I have to divide. That's the inverse operation. And if it's a 5x, I'm going to divide by whatever this coefficient is. So I'm going to divide by 5 on both sides because these 5s will cancel out. Times 5 and divided by 5 are inverses, so that cancels out. And I'm left with just 1x, or just x. And on the other side, it's 20 divided by 5, which is 4. So my x is equal to 4. So we just take it one step at a time, undoing each operation one at a time. All right, for number 5, it says on the back, explain in words using some of the new vocabulary how you solved number 4. Remember to explain why you did each step. So I'm going to do it on the side here so we can look at number 4 while we're doing it. But we have to say, what is the first thing that we did? So we looked at number 4, 5 times x minus 8 equals 12. And we saw that there was subtracting 8. There was a constant of 8 being subtracted. So we started with that. We decided in order to isolate the variable, we got to try to get rid of the constant first. So I'm going to start my example saying that. In order to isolate the variable x, first, I need to move the constant of negative 8 to the other side. So I want to think of this as if someone was absent, I'm explaining to them how we do a two-step equation so they could understand as if they were here for our lesson. So in order to move the negative 8, I need to do the inverse operation which is to add 8 on both sides. So that's the first step. So we talked about what our first step was and how we knew what we needed to do. We looked for the constant and we knew we needed to do the inverse. So we did the inverse of negative 8, which is positive 8. We added 8 to both sides. Then we're left with this 5x equals 20. So then we have 5x equals 20. Next thing we did is we divided by 5. Why did we do that? To get rid of our coefficient. So next we have to remove the coefficient of 5 from x. 5 is being multiplied by x, so the inverse is to divide both sides by 5. After that, our x is isolated. I could even add that one last little bit in over here. Then the variable is isolated. And we know it is equal to 4. There you go. A very long explanation of 5, but it's very thorough. It uses some really good words. We used the word constant. We also used inverse operation. And so whenever we're writing an explanation, we're thinking about our communication. We want to make sure we're communicating very thoroughly. So someone could read it and basically get the gist of how to do any problem similar to this one. So we used the word constant, we used the word inverse operations, we also used the word coefficient. We also said isolate the variable, which is another good term to use, very mathy. So we want to try to use as many vocab terms as we can. Try to stay away from really general terms and be very specific. So notice we didn't only write words, we also put numbers in there, and so that's really important that when you're talking about the constant, you say which one the constant is, so you're specific to your example. We used the word inverse again. We used the word isolate again. So those are all really good vocab words to be specific, and we explained what each one was. So if you need to go back and review any of this again, feel free to stop, rewind, and watch any part again that didn't quite sit with you well and you need to review.